Right, so today we're going to be making circuit boards. There are a lot of different ways to do this, but I'm going to show you the way I'm going to do it. So we're trying to create something that looks kind of like this to make all of our electrical connections for us. We start out with a regular one-sided copper clad board that has a thin layer of copper on the top and then fiberglass board underneath it for rigidity. We start out by spray painting it with a ordinary black spray paint. Then we hit it with the laser to burn away the paint where we don't want any copper to be. We then etch it in a ferric chloride solution, which removes the copper where there isn't any paint to protect it. After that, we just go with a regular acetone bath to remove the paint. My first attempt at this was a PCB for a latching circuit for a torch that was built out of garbage. Either which way, it went all right, but definitely left some room for improvement. Conceptually, the process is quite simple, but in practice there's a lot that can go wrong, especially with the lasering of the paint step. If your feed rate is too high, you're sacrificing quality. If your feed rate's too slow, you're going to take forever to laser the board. Same goes for power. If your power is too high, you're going to heat up the copper too much. There's going to be kind of like a heat creep, and it's going to delaminate from the fiberglass. And if the power is too low, you're not going to burn away any paint at all. Alrighty, it's etching time. Time to use my personal protective equipment. I honestly have no idea if nitrile gloves are going to get eaten by this ferric chloride and just eat into my skin, leaving me with nothing but stumps. Or if it's going to save me. I could Google it, but nah. Or some of that, yeah. Corrosive chemicals. La da da da. And then we place the components. Easy. Best jump cut ever. Alright, I have turned on the camera so that you can see my sadness when the PCB does not work. Genuine first time trying to see if it actually works. I plug this in, the LED should switch on. So I don't know if it's going to make good enough contact, but I'm about to find out. Oh shit, it's on. That's what it's meant to do. What happens when I press the button? Fuck. So the problem I was having here had to do with the tool paths that the laser was taking. As you can see here, it was scanning horizontal lines and the laser focal spot is really small. It was leaving tiny little tracks in between, which was making continuity and connection where there isn't supposed to be. But I eventually figured out what the problem was. Quickly! We have to film it before it stops working. Oh yeah. Press that button, light comes on. Oh, it goes off. Holy shit. My latching circuit works. Would you fucking believe it? Because I wouldn't believe that. 7 million years of troubleshooting later. The second PCB I tried this on was for a Game Boy. A tiny little Game Boy that I was making. And previously I designed in Altium Circuit Maker, which is the free version of Altium 360. And I designed this next one in Easy EDA, which I found to be quite a lot more intuitive, but maybe it's just the fact that I've never designed anything or used the software before in my life. Alright, so the universe obviously thinks I don't have enough problems already, so what it's doing is, it's hard to see here, but this side of the board is lifting up because it's warming the plastic underneath it, which then warps, lifting this side up, which brings it out of the focal length. And then see how it's like engraving nicely here, and then now it's like black shit over there? Yeah. Gotta tape it down or something. Are you tired of your PCB getting all floppy on you? Well, look no further. This one simple trick will keep it hard all night long. Gluing it to a board. So it seems to have occurred to me a little too late that hot glue might not be the best adhesive for holding down something that is getting hot. Here seems to be fine, but it lifted up a little bit here near the end. I think I can just wipe this away. I don't think it's a massive issue, but it really does need to be perfectly level and within the focal point throughout the entire process. Okay, so I've scratched with a utility knife in between most of the traces, because this way, if you can still see the scratch lines after etching, then we know that they're necessary. Also, I've left these two right here. They could make connection possibly if, because I haven't scratched between them. So if these two are continuous after etching and the others aren't, then we know that this is obviously not a valid technique and we need to try something else. Oh yeah. Ah man, it is leaving a bit of copper in between, isn't it? That's unfortunate. So the board I just made will work fine for that project, but I'm just kind of unsatisfied because of those little lines that was left there. And since that PCB just barely worked, I thought I may as well make things much harder for myself and try and make a breakout board for this little ESP8266 chip. So we'll see, because the spacing is quite a lot closer. So I cranked up the lines per millimeter in laser GRBL before lasering the paint, and wow, it really increased the quality a lot. I low-key had an erection after looking at this thing for the first time. So crisp. Oh my god, it's fucking flashing. Oh my god. Is it about to flash? Did it flash? It says it's resetting. Oh, I don't think it has the reset pin connected. Let's reset it manually. Oh wait, we need to disconnect this line. And then reset it. Yo! It flashed! Oh my god! Damn! First time anything has ever worked first try. Wow. Turns out following tutorials on YouTube does work out in your favor.